subject description nyo talaga is data and digital communications. Yet, we're going to discuss first digital communications before data communications. Okay? So, ang hirap naman mag-data communications tayo, definitions regarding digital communications. Okay, so first things first, we're going to discuss um, the basic block, basic building block. Like yung pumapasok sa akin yung basic building block of matter. Okay, so we're going to discuss the basic block diagram of a database. Is my annotate. Some books na hindi source yung nakalagay. So some of nakalagay dito ay transmitter and dito naman ay receiver. Okay, so TX stands for transmitter while RX stands for receiver. Okay, so a block diagram of digital communication system starts with okay, so an information source. So there are different types of information source. So it can be an image, a video, or a sound signal. Okay, audio, video, image, or okay. So example of an analog signal. Okay, so papasok si analog signal dito. Example sound signal. Okay? So ano bang ginagawa ni input transducer? Okay? So input transducer is a type of transducer that converts that electrical energy into an electrical signal. Okay? So from non-electrical or physical input and converts it to electrical signal. Okay? Nakakasabay?
Copy. Ay.
Hello? Am I breaking up? Choppy?
Choppy po sir, medyo po.
Choppy ako?
Opo, sir.
Medyo late po pati yung
Medyo po,
Hindi.
sir.
Choppy? Hindi.
Medyo po.
Gago. Lo. Oh, pado. Bakit pag sa inyo laging choppy? Nag-discuss ako ng math, nagdi-discuss ako ng higher math, nag-discuss ako sa kabilang section. Hindi naman choppy. May sumpa kayo eh. Wait nga. Okay naman. Hindi naman maulam. O ngayon, clear na? Clear?
Yes sir.
Okay,
Yes,
so magiging input niya, so that's analog signal will be converted into a digital signal. Okay? So ito ay digital signal. So ang output mo yung electrical signal. Okay? So during our last discussion, I already mentioned some types or examples of transducers. Okay? So examples of transducers are microphone, loudspeaker, antenna, ano pa? Thermometer. Okay? So those are just some of the examples of transducers. Okay? So a transducer is a electronic device that of or non-addition of terms lang. So halimbawa, si digital signal lumabas na kay analog to digital converter. So diyan papasok si source encoder. Okay? So nabanggit ko last time, so what does the source encoder do? So the source encoder does remove redundancy. Okay? So it removes redundancy at ang tawag po sa output ng source encoder ay source code. Okay? Tandaan, the output of the source encoder there is code, source code, and usually that is a digital signal or in digital signal sequence or sequence form. Ano yun? So halimbawa, ang output niya ay 0101. Okay? So pwedeng output niya dito ay 0101. Okay? Nakakasabay pa?
Yes po, sir.
Yes po, sir.
Okay, so bukod sa it reduces redundancy, it compresses or it compress data into minimum number of bits. Okay, so anong ibig sabihin nun? So halimbawa, nire-remove niya, so meron tayong data. Halimbawa, may data tayo na 010101 then 000. Okay? So basically, what the source encoder do is first, it removes redundancy. Second, it removes unnecessary bits. Okay? Ito yung mga unnecessary bits. I-remove niya yan. Okay? So bakit nire-remove yung unnecessary bits? Okay? Removing of unnecessary bits helps the source encoder in bandwidth efficiency or bandwidth utilization. So, anong ibig sabihin ng bandwidth? Okay? So, last time, I already discussed what bandwidth is. Okay? So, basically, bandwidth is the difference between the maximum frequency and the minimum frequency. So, yan yung bandwidth in digital communication. Okay? So, it can also be defined as range of frequencies. Okay? Range of frequencies na pwedeng pumasok sa transmission line or in networking, it can be defined as a range of memories, range of memory data. So basically, when we talked about bandwidth, we're talking about frequencies in units, hertz. Ang unit niya ay hertz, represented by the abbreviation HZ, hertz. It hertz, okay? Named after Heinrich Hertz. Heinrich Hertz. Okay? Nakasabay pa?
Yes po.
Okay. So after lumabas ni source code, okay? So papasok naman channel encoder, okay? So what's the channel encoder do? Okay, first, provides immunity. Okay? Second, it's error correcting bits. So, ano yung error correcting bits? Okay? So, halimbawa, ang output ito ay 0101, original data. Okay? And then, maglalagay siya ng echo bits. So, halimbawa, 01. For example, 011. Okay, 1. So, ang tawag po dun sa 011, those are the error correcting bits. Okay? So, bakit naglalagay ng error correcting bits? Halimbawa kasi, yung code, dumaan encoder, so, may mga noise, okay? So, possible, yung mga data, ma-alter, okay? What does the channel encoder do? For that, okay, lalagay siya ng error correcting bits. Okay? Tapos, ang output po naman ay tinatawag channel code. Okay? So, ang output ni channel encoder ay tinatawag na channel code at yung nasa unahan ay tinatawag na error correcting bits. Okay? So, for that, sige, linisin ko muna. Di ba na-erase ko? Erase. Okay? So after that, dadaan naman siya kay digital modulator. Ay, nawala na naman ako. Grabe. Okay? So after, so may output na tayong tinatawag na channel source. Channel code. Channel source code. Right? So that digital signal represented in binary sequence or by form into an analog signal. Ayan. So kaya meron tayo digital to analog converter. So dadaan na siya ng modulation. So when we talked about modulation, sige, may papanood pala ako para mas maintindihan niyo yung modulation. Ay, YouTube pala muna. YouTube. Nagigets? Nakakasabay pa ba?
Yes po, sir.
Okay. Modulation. Share. So hindi ako naka-premium May commercial. Skip ads.
The third technique is
Nakikita na yung screen ko.
Yes.
Kaso loading. Sinong mabilis ang wifi? Come on. Ko. Sino pwedeng mag-play kan? Wala. Sino pwedeng mag-share ng sila kung links?
Modulation is one of the
Yan.
most frequently used technical words in communications technology. One good example
is that of your FM radio, where FM stands for frequency modulation. In this video, we are going to learn the basics of modulation techniques and see how they are applied in modern cellular and communications technology. Frequency and wavelength of a wave are inversely connected. Humans have the capability to hear sound frequency from 20 Hz to 20 kHz. But if a radio tower transmits electromagnetic waves of the same frequency, the size of the antennas required will be really high. In the antenna video, we have already seen that the size of the antenna is proportional to the wavelength. If we had transmitted the electromagnetic wave in the same frequency of sound, the antenna size required would have been in the range of kilometers. This is why modulation, before the electromagnetic wave, we modulate this. of paper, it won't go far. Now, tie to a stone and throw it. In the modulation process, one of the properties of the carrier signal is varied in accordance with the message signal. For example, the frequency of the carrier signal is varied according to the amplitude of the message signal. This technique is known as frequency modulation. Please note that the frequency of a carrier signal is always high, which means the modulated signal is also of high frequency and energy. The value of the original signal can be easily retrieved from the frequency of the modulated signal. In the same way,
Share. Ayan. So, pinakita ko lang kung ano yung modulation. Basically, when we talked about modulation, so ganito siya. So, given a sine wave, halimbawa, meron tayong sine wave. So, ano ba ang equation ng sine wave? Tandaan niyo. So, the standard equation of a sine wave is what? So, y is equal to a sine 2 pi x t minus angle or the phase shift. Okay? So when we're dealing with modulation, we are varying some of the properties of the digital signal. Okay? So what are those properties? First of which, as you can see, is A. So this represents the amplitude. Okay? So this is the amplitude. Okay? So this one, so kaya meron tayong tinatawag na amplitude modulation. Okay? Amplitude shift keying. Okay, sa digital. So dito naman, a phase shift keying. So this is your phase. So may tinatawag tayong phase shift. So ibig sabihin ng phase shift, so saan nagsimula yung signal mo. Okay? So kung titingnan mo dito, ang origin niya ay 0. Okay? So ang phase shift niya ay at origin which is 0, 0. Okay? So that is pag-aaralan natin yung phase shift keying. And then yung frequency naman, so when we talked about frequency, that is basically 1 over t. So 1 over the period. Okay? So ano ba yung period? So basically, your period is from here up to here. Okay? So that is your 2 pi. So that is your period. Okay? So to be able to get the frequency, so that is 1 over 2 pi. Okay? So frequency is in unit hertz. Okay? So based on what you've watched, modulation deals with varying the property of carrier signal into a high frequency modulated signal. So basically, all the carrier signal that being modulated is in high frequency. Thus, the modulated signal being produced will also be in high frequency. Okay? High frequency carrier signal, high frequency modulated signal. Okay? Nakuha?
Yes po.
Nakuha po? Hoy.
Yes, sir.
Okay, good.
Yes po, sir.
Okay, so kanina, sige, balik tayo dun sa ating block diagram. So as you can see, the digital signal is again converted into analog signal. Why? Because the channel or the medium only reads an analog or to a medium is an analog signal. Okay? So that is why during this phase, the digital signal is converted again to analog signal. Okay? So papasok siya sa channel. So this is, ang output niya ay analog. Okay? So si channel allows the analog signal to be transmitted from the transmitter side to the receiver side. Okay? And then, so ang output niya ay analog. So nakita nyo, nagkaroon tayo ng digital demodulator and analog to digital converter. So ang output ay analog, then the digital demodulator, and in this process, the analog signal will then be again converted into an digital signal. So kanina, 'di ba? Meron tayong output dito na 0110110. So this is called the error correcting bits, and this one is called the channel code. Okay? So kung dito siya 0110 0110. Ano tayo? Digital demodulator. Gusto na yung digital demodulator ko. Ayan. So as you can see, the digital demodulator is the first step in the receiver end. Okay? So all of this is in the transmitter side, and this one is in the receiver end. Okay? So pagkatapos, so magiging output ito again is a digital signal. Okay? Papasok na tayo kay channel decoder. So ano ba ang ginagawa ni channel decoder? So it performs error correcting bits. It perform error corrections. So halimbawa, kanina si channel decoder, it adds error correcting bits, while the channel decoder perform error correction of that error correcting bits. So makikita niya na si 011 pala, this one, si 011 pala ay error. So ang i-output ni channel decoder ay 0110 lamang. Okay? Nakukuha?
Yes, sir.
Okay. So source decoder again, it will output a digital signal. Okay? So digitized ulit yung sample signal. Then lalabas kay output transducer. So ang magiging output dito ay digital, then sa stage na to, i-convert niya into analog. Ano ba example ng mga physical output? Loudspeaker, di ba? Then ang output signal niya ay yung received signal mo. Okay? So basically, that is the block diagram of a digital communication system. Okay? So gusto ko lang kayong ma-familiarize kung anong meron sa digital communication system, definition of terms, para mas lumawak yung vocabulary nyo in terms of digital communication system. Okay? Next. So after discussing the block diagram of digital communication system, so we're going to talk about the advantages and disadvantages of digital communication system. Okay, first of which is the storing capability. So how is it that the storing capability is one of the advantages of digital communication? Why? So as you can notice, in this modern world, we are fond of using smartphones. Okay, so these smartphones are capable of storing large amount of memory and data. You can save thousands of pictures, videos, images, sounds, and musics. Okay? Gigabytes. Okay? So, gigabytes of data. Gets? Kung bakit meron siyang storing capability?
Yes po.
Hoy. Okay. So, isa lang tagay nagpo-confirm. But 43 kayo? Ay, oo nga. Yung 43 pala yung konti. Okay? Next. Inexpensive. So, that is self-explanatory in a sense that cost is less when using digital communications. Okay? Ano to? Ano to yung question mark? Bakit nag-question mark ka, Ramos?
May nag-chat po sa akin, di ko po, share po dito.
May tanong ba? Okay. Okay, so next is the use of repeaters. Okay, so basically, when a signal is traveling along distance, so halimbawa, this is your signal. So the tendency is that that some of the properties of that digital signal will be lost or decrease or degrade. Okay, so yeah. So what the repeater do is that it prevents the loss of data or the loss or the decrease of the property of the signal. Okay? So, yan. So, babalik siya sa digital signal. Okay? So, with the use of repeaters, the loss, decrease, and degrade of property of the signal will be eliminated. Okay? Privacy and security through the use of encryption. So, again, so that is self-explanatory. So, with the use of digital communications, we were able to encrypt, okay, our data. So, yun yung encryption natin ng data, di ba? Pwede natin siyang itago with encryption para hindi siya ma-access, okay, for security purposes. Okay? Next, so data compression, error detection, and error correction is possible. As I've already discussed, using channel decoder and error detection and error correction are possible. Okay? So, flexible hardware implementation. So, basically, you are familiar with Arduino and Gusdino, di ba? So, when we are changing programs or we are about to modify some programs, what we do is just delete the program, then i-load natin yung bagong program dun sa hardware natin. So that is flexible hardware implementation. Okay? So pwede din siyang halimbawa ikakabit natin yung microcontroller or microprocessor, diba? So what we're going to do is just modify some programs, then yun, pwede mo siyang isalpak. Okay? Next, easier and efficient multiplexing by TDMA and CDMA. So we're going to discuss TDMA and CDMA. So that is time division, multiple access, then code division, multiple access. Easier and efficient multiplexing. So what is multiplexing? Shared. So basically, when we are dealing with multiplexing, so multiplexing is defined as so multiplexing allows multiple signals to be transmitted into a single data link. So ano ibig sabihin nun? So halimbawa, so this is your muxer. MUX, okay? So that is your multiplexer. And this is your MUX or the multiplexer. Okay? So this is your data link, single data link. So this is your N. Ano bang drawing ko dito? And input lines. And this is your and output lines. So what the multiplexer or multiplexing do, it allows simultaneous or multiple transmission of signals into a single data link or across a single data link. Okay? So, yun yung ginagawa ng multiplexing. So, through the use of digital communications, you can use multiplexing using multiplexer and the multiplexer. Okay? Nagets? Andyan pa ba kayo?
Yes po, sir.
Yes po, sir.
Yes, sir.
Okay. So, dako naman tayo, Tagalog ng Tagalog. So, punta naman tayo sa disadvantages of digital communication. Okay? So, first is bandwidth is high for channel. Okay? So again, I have already discussed to you what bandwidth is. Again, to repeat, so bandwidth is basically the range of frequencies and the difference between the maximum frequency and the lower frequency. So, bandwidth is high for channel. So, why? So, simple example. So, kung nasa bahay tayo, so kailangan natin ng mabilis na transmission of data. So, using internet connection. So, ang bandwidth na kailangan natin, for example, ay 500 mega Mbps, 500 Mbps, o naman, 200 Mbps, okay? So, halimbawa, para gusto nyong walang loading ng picture, ng video kapag nagba-browse kayo, you're aiming for a greater bandwidth. Okay? So that provides greater transmission of data. Yet sa digital communication, somehow that is positive and negative. Positive in a way that to be able to have a greater bandwidth, it will provide you greater transmission of data. Okay? Pero, mahirap i-achieve yung mataas na bandwidth. So that is why it is considered as disadvantage. Okay? Number 2, synchronization is compulsory. Why? Why synchronization is compulsory in digital communication? It is for the reason that if synchronization is not present in digital communication or digital signals, to be exact, magkakaroon tayo ng maraming error. Okay? So, mahihirapan si channel decoder na i-correct or i-detect yung mga errors na yon. Okay? Next, high power consumption due to multiple stages. Okay. So, dahil as you can see, doon sa pinakita kong block diagram ng digital communication, there are multiple of stages, okay? So making the system or making the electrical circuit and the electrical design of a digital communication system bulky, thus it consumes high power, okay? So kapag complicated yung circuit, complex circuit, dahil maraming stages, for example, kung nakita nyo, naging output niya naging digital to analog, analog to digital, digital to analog, then analog to digital. Okay? So that is an example of a complex circuit. Okay? Gets? Gets po ba? Thumbs up po kung na-gets. Thumbs up. Napilitan lang eh. No? So, actually, ito lang. Sobrang tahimik ng class nyo pala kapag online. In comparison dun sa kabila, medyo matanong din sila. So if you are if you want to ask or if you are curious on as a topic, so you can ask naman directly para at least ma-entertain ko kung may tanong kayo. And kung kung nalilito kayo doon sa diniscuss ko, pwede agad kayo magsalita para masagot ko yung tanong niya. Okay? Kesa naman sa exam pa kayo magtatanong, okay? Sa orasan ng exam. Okay? Okay. So, punta na tayo sa computation. Okay? So, in digital communication, you will encounter different terms, most of which is the bandwidth, the maximum data rate, information capacity, transmission time, baud rate, bit rate, hertz. So those are some of the terms you will encounter when you're dealing with digital communication. Okay? So in digital communication, there is so-called the Hartley's law. So Hartley's law states that the total amount of information
Permission to interrupt
that
po.
can be transmitted is proportional
Sir, choppy po kayo, sir.
to frequency range and uh, so basically states that they some of the
Sir, napuputol po kayo.
notes and some okay. Game. Putol pa din, hindi na.
Okay na.
Sir.
Okay na po, sir.
Good. Okay, so medyo marami itong computation, so game. So Hartley's law is just only states that information capacity is directly proportional to its bandwidth and transmission time. Okay, so when the bandwidth and the transmission time increases, so the information capacity also increases. So when the bandwidth and the transmission time increases, thus the information capacity also decreases. Okay, so we have information capacity, bandwidth, and transmission time. So information capacity, ang unit po niya ay bits per second. Ang unit po ng bandwidth, okay, that is hertz, and the unit of transmission time is seconds. Okay, for Shannon limit for information capacity, some of the books called it Shannon-Hartley limit for information capacity. Okay, Shannon-Hartley. So named after Claude E. Shannon. So Claude E. Shannon. And si R Hartley. Nalimutan ko lang yung R. Balikan ko na lang siguro after. Okay? So we have the information capacity I or C is equal to B log 1 plus signal to noise ratio or 3.32 B log 10 1 plus signal to noise ratio. So basically, these formula are just the same. It's just that this one is in the base 2 and this one is in the base 10. Yet, it is converted by a factor of 3.32. Okay, so ang gagamitin na lang natin formula ay ito. So that is I to B log 1 plus signal to noise ratio. Okay, so signal to noise ratio, when using the formula, should be in its normal value or in its factor value. So when I say factor value, it should not be in decibel value. So mag-example tayo para mas malinaw. Okay? Example problems. So for a typical telephone line with a signal to noise ratio of 30 dB and an audio bandwidth of 3 kHz, define the information capacity. Okay? You can copy or you can take a picture of it, then send nyo na lang sa GC mo. Okay? So, solve natin. So, in the given problem, we are asked to find the information capacity I. So, that is your required. So, the given are, first is your signal-to-noise ratio, which is equal to 30 dB, and your bandwidth of 3 kilohertz. Okay? So, our formula is I, B log, 2B log, 1 plus signal to noise ratio. Okay, remember, when using this formula, the signal to noise ratio should not be in its decibel form, but in its normal value or power factor value. So factor value or its normal value. So to be able to convert the decibel value, what you're going to do is use the formula dB for the decibel value 10 log of x. Okay? So that x is your normal value or your factor value. Okay? So dB is equal to 30 is equal to 10 log of x. Okay? So shift solve, x is equal to, kuha po ng calculator. Anong sagot? Anong sagot, Orgiles?
Wait lang po, sir. Sinasunod lang po.
Anong sagot? Kaya today?
Sir, 30 po ba yun?
Yep.
10 po ba, sir, yun? No?
Sir, ano lang po, 1 minus 10 cube po yan eh.
So ang sagot ay 1,000. Okay?
1,000.
So, I is, your bandwidth is 3 kilohertz. So, that is 3,000 log base 2 1 plus 1,000. Okay? So, kung pipindutin po natin sa calcu, so that is 29,901.68 BPS. And your answer should be in scientific notation. So, that is 29.90 kilobits per second. Or kung wala sa pagpipilian, kung multiple choice yung exam, so that is round up to 30 kilobits per second. Okay? Nakuha?
Yes po, sir.
Okay. So move on na tayo. So in digital communication, actually you will encounter a lot of computation and memorization of formulas. Look. Okay? For example number 2. Number 2. For a satellite TV channel with a signal-to-noise ratio of 20 decibel and a video bandwidth of 10 megahertz, find the maximum data rate. In the first question, you are asked to find the information capacity. in this second question, you are asked to find the maximum data rate. Okay? So that is just the same. Okay? So the information capacity and if the maximum data rate ay hinahanap, so that is your information capacity. Pero there are times na information capacity and the maximum data rate are given. Okay? So mamaya may ganung example. So solve lang natin for a satellite TV channel with a signal to noise ratio of 20 decibel and a video bandwidth of 10 megahertz, find the maximum data rate. Again, your required is the I and your given are signal to noise ratio, which is equal to 20 decibel, your bandwidth, which is equal to 10 megahertz. Okay? So 10 megahertz meaning, so that is a factor of mega, which is equal to 1 times 10 to the 6. When it's giga, so that is 1 times 10 to the 9. Okay? So you should be familiarizing yourself with the different scientific notation. Okay? So first things first, we need to convert this decibel value to its factor value or normal value. To be able to do that, again, you need to use the formula TD is equal to 10 log of x. Okay? So this will be equal to 20 is equal to 10 log of x. Then x, by using shift solve, is equal to 100. Okay? So using the formula I is equal to B log to the base 2, 1 plus signal to noise ratio. So I is equal to B, so that is 10 times 10 raised to 6 log 2 1 plus 100. Okay, so kung pipindutin po natin sa calcu, pakipindut po sa calcu, so your answer will be equal to 66.58 megabits per second. So that is your information capacity or the maximum data rate. Nakuha? Nagets?
Yes po, sir.
Okay, nakakasabay?
Yes po, sir.
Okay. Good. Okay. So, yun. Move on na tayo sa next problem. Sit work. Gusto niyo mag-sit work? Silence means yes. Okay. So, gusto niyo mag-sit work? Sit work tayo. Okay, so get maga pa naman. Ay, hindi na lang pala sit work, okay? Kung sino na lang una makasagot, first 5 na makapag-send ng solution nila sa GC will have additional 5 points sa first quiz. Okay? Get your ball pen, calculator, first 5 na makapag-send sa GC ng kanilang solution. So, yung papel nyo should be with your names and section. Okay? Ready na? Ready na ba? May papel at ballpen na?
Wait lang po, sir.
Okay. Okay na? Ready?
Okay na po, sir.
How about the others? Thumbs up kung ready na. Okay. So your question is ito. Go. For a typical telephone line with a signal to noise ratio of 30 dB, what is the required bandwidth to achieve the maximum data rate of 3 Mbps? So your final answer should be in scientific notation kilo. Go. Yung sagot nyo dapat may picture ha. Dapat nakita ko nag-solve. May solution, required, may given. Wala pa rin nakakasagot. O wala nagsasagot. May nakasagot na ba?
Hindi pa po sir, tapos wait lang.
Di pa tapos? Okay, last 1 minute. Okay? So tama. So tama naman yung nag-send. So solve na lang. Tama siya. So meron kang plus 5 sa first piece natin. Solve natin. Okay? So so the given is a signal to noise ratio. So ang hinahanap natin bandwidth. So may given din tayo maximum rate ng 3 Mbps. Okay? So i-solve natin. Share screen. Okay? So required is bandwidth, and ang given natin ay signal to noise ratio of 30 dB, and your information capacity is 3 Mbps. Okay? Again, first step is to convert the signal to noise ratio to its normal value. So that is 10 log x is equal to dB. So that is, nasolve na natin kanina, x is equal to 1,000. Okay? So, information capacity B log 1 plus signal to noise ratio. So, I is equal to 3 times 10 to the 6 bits per second. Bandwidth, so that is, ang hinahanap, log 2, 1 plus 1,000. So your bandwidth is equal to 3 times 10 to the 6 over log 2, 1,000. Sorry, that is 1,001. Okay? So, pag pipindutin nyo sa CalQ, bandwidth is equal to, pindot sa CalQ, 3 times 10 to the 6 log 2 1001, that is 396.45 bits per hertz. So ay mali pala yung sagot mo, dapat in unit hertz ha. So bandwidth is equal to 300.99 hertz. Okay? So, yan. Picture nyo. So, the answer is 300.99 kilohertz. I mean. Okay? Na-gets? Na-gets po ba?
Yes po, sir.
Yes po, sir.
Okay, so clear lang natin. So last problem na para makapag-dinner na tayo na maaga. Don't forget the correct units, okay? So when we talked about bandwidth, we're dealing with hertz. When we talked about information capacity, we are dealing to bits per second. Yet your answer should be in scientific notation. It can be kilobits per second, megabits per second, or gigabits per second. So when we're talking about signal to noise ratio, it can be decibel, yet when using the formula, the decibel value should be converted to its factor value or its normal value. Using the formula, dB is equal to 10 log x. Okay?
Oh my God. Paano 10 log x?
Hindi ko na-gets yung 10 log.
Anong hindi mo na-get? Sige, go. Huy.
Sir, ano po yung ano?
Ano?
Sir, yung ano po? Yung 10 log x po.
Okay, again, so signal to noise ratio, when using the formula, should be converted from decibel value to its factor value or normal value. To be able to do that, you need to use the formula dB, or the decibel value, is equal to 10 log of x. So that x represents the normal value or factor value of that given decibel value. Kuha?
Yes po, sir. Thank you po.
Okay na?
Nalito lang po ako, sir. Yes po.
Okay. Okay. So next. So last example. So for question number 3, so consider that a 100 kbps data stream is to be transmitted on a voice grade telephone circuit with a bandwidth of 3 kHz. Is it possible to approach error-free transmission with a signal-to-noise ratio of 10 decibels? That justify your answer. Okay? As you can see here, we are given a maximum data rate of 100 kbps, a bandwidth of 3 kHz, and a signal-to-noise ratio of 10 dB. Yet, we are asked if is it possible that the maximum data rate and the information capacity will approach an error-free transmission. So how is that possible? Or is that possible? Or what are the conditions to be met to be able to say that it will have or it will approach an error-free transmission? Okay? So, sige, isulat lang natin yung mga given. So, we are given an information capacity. No, we are given a maximum data rate. So, that is maximum data rate or R. So, maximum data rate is represented by R. If it's given, so that is R. R is 100 kilobits per second, and we are given a bandwidth of 3 kilohertz and a signal-to-noise ratio of 10 decibel. Okay? Okay, to be able, tandaan, to be able to approach an error-free transmission, the maximum data rate should be less than or greater, should be less than or equal to its information capacity. So remember this condition, so that the maximum data rate should be less than or equal to the information capacity. Okay, so to be able to tell if it's an error-free transmission, again, we need to compute its information capacity. So I is equal to B log 2 1 plus signal to noise ratio. So I is equal to the bandwidth is 3 kilohertz, so that is 3000 log 2 1 plus, again, we need to convert the decibel value to its factor value or normal value. So that is 10 log x 10 dB. So x is equal to 10. So this will be equal to 10. Shift solve nyo lang to. So this will be equal to I is equal to 10.378 kilobits per second. So ang R daw natin ay 100 kilobits per second. Should be less than or equal to 10.38 kilobits per second. Okay? So, is this an error-free transmission? Yes or no? Huy.
No po, malaki po masyado yung discrepancy.
Correct. So, this is not an error-free transmission. Okay? So, that is not equal. Okay? So, yun lang. Clear ko lang. Okay? So, any question? Any clarification? Saan kayo nalito? Saan kayo na-confused?
Sir,
Sir,
lang.
Oh, go. Go, Devilis.
As lang po namin kung ano po yung meaning po nung R.
R, so that is maximum data rate.
Thank you po, sir.
Okay, so na what ang given maximum data rate? So tinatanong yung maximum data rate mo. So that information capacity is can be a minimum data rate or a maximum data rate. So pag tinanong, minimum data rate, ibig sabihin, mababa yung information capacity mo. So that is minimum data rate. Pero information capacity pa din. Nakuha? Hoy.
Ulit po, sir.
Okay, so information capacity. So when we're dealing with information capacity, it deals with maximum and minimum data rate. So when you are asked what is the information capacity, what is the maximum data rate, and what is the minimum data rate, it talks about information capacity. Okay, but when there is a given maximum data rate, ibig sabihin nun, ang hinahanap mo ay minimum data rate information capacity. So kagaya kanina, so ang nahanap natin ay yung minimum data rate, which is 10.38 kilobits per second. When compared to the maximum data rate, 100 kilobps, so doon natin nasabi na that is not an error-free transmission. Kuha? Hindi pa din. Gets na? Okay na?
Medyo po.
May tanong lang po ako.
Okay, sige, go.
Pag po ba sinabi po na yung wala po siyang margin of error, dapat po ba ay exact po siya kahit po dun sa decimal point para po matawag po ba siya na walang error? Or dapat po close or congruent lang siya?
Okay, so when we're dealing with numerical errors, specifically rounding errors or rounding off errors, truncation error, okay lang naman yun. Okay? So, sige, para safe tayo lahat, so 2 decimal places. Ayan. Or yung tanong mo ay in terms of error detection.
I mean po yung pong range halimbawa ay plus minus 5% po nung original value.
Ano, tolerance? Hindi, kapag nagko-compute tayo, sige, 2 decimal places. Pero depende, pag multiple choice, syempre, kung ano yung pinakamalapit na tamang sagot. Nasagot ko ba yung tanong mo?
Yes po. Thank you po.
Okay. Other questions? Sige, tanong lang. Kasi kapag nag-exam na tapos nalilito pala kayo sa pagsosolve, edi wala kayong masasagot. Wala na? Okay. One, going twice. Okay, so wala na. So, may tatanong? Wala na. So next week, will be... sige, sino? Sorry.
Paano po malalaman kung maximum or minimum data rate po ang given?
Okay, so... to be able to distinguish if it's a maximum data rate or a minimum data rate, kukumputin mo, syempre. Kung may giving maximum data rate at ang na-compute mo ay mas mababa sa maximum data rate, so that will be your minimum data rate. Gets?
Ano po ba sir yung area of measurement para matawag po siya na siya po yung data rate? Ano po yung unit niya?
Data rate, bits per second. So kapag ang unit niya ay naka-bits per second, so that is your data rate. Rate kasi per second.
Sir, yung data
Okay.
rate po ba ay equal po or another term for information capacity po?
Yeah.
Since yung unit po ay bits per second po.
Yep. Question? Wala na? Okay, so next week, we'll be meeting face-to-face. Yay! Face-to-face. So, same, ano na siya, same time. Wait lang, I'll check. Ayun. Okay, so yun. Anong oras natin? 4:32? 6, tama ba?
Yes po, sir.
Then, TTH, no? TTH nga ba kayo? Tama, no? TTH. Okay, so kung wala nang question, bye! Thank you!
Thank you po, sir.
Thank you, sir.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Happy dinner po.
Okay.
Thank you po, sir.
Thank you po, sir.
Thank you, sir.